All right, so last lesson of the week, we're going to be talking about side triangle congruence. We'll do that on 52 and 53. Remember, you're going to have to be able to specify between them. So go ahead and turn to page 52. And label that in 53, side. Side. Triangle congruence. And I forgot to put 5.4. I'll write that, put 5.4. 5.4, side. Not SS. It's not the SS. Triangle congruence. .4. Side. Triangle congruence. Page 53. All right, you're going to tear out page 256. In case you didn't hear me, I'm writing it down. 256. We're not cutting out as much today. We are very much going to be writing, drawing. You'll need a straight edge. I'm not sure if I have one. I got to see if I do. You need to cut out from 256 the theorem and the triangles right underneath, and that's it. You can throw away that paper now. I blew that in on page 52. We're mostly just going to do proofs. We're going to do 3 proofs. Okay, so just like before, we're going to talk about the proof. We're going to do a very rough kind of proof, and then we are going to do some actual proofs instead of just like rough proofs. All right, so this one says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So you'll flip back here, put this one in side. Here's the picture we got going on. All 3 sides are congruent to each other. So let's talk about example 1. In the triangle shown, AB is congruent to DE, AC is congruent to DF, and BC is congruent to EF. We're going to cross out this part that says use rigid motions. We could, rotate it and they would be congruent, but that's not what we want to do. We want to decide if these are congruent, and we don't have angle measures or anything like that. They went ahead and just said, hey, all these sides are congruent, so therefore, by side, triangle A, B, C is congruent, A to B to C, D, E, F. That one wasn't like yesterday's couple. That one's not bad, because it already tells us the 3 pieces that we need. Okay. All right, so you're going to need a straight edge. You're going to need your highlighters, because we're going to highlight give and improve like yesterday and the day before. We're just going to do some proofs now. Anytime you're in a room, we're doing 1, 2, and 3 proofs. We're going to do 1 here and then 2 and 3, but we're staying on 52 and 53. But it doesn't matter if 1's here and 2's here and 3's here. It does not matter as long as they're on pages 52 and 53. So let me see if I've got a straight edge out. I do. All right. Number 1. I'm going to put my glue up first, because my workspace is a little messy and it's getting on my nerves. All right, number 1. Given that WZ is congruent to WX and WY bisects ZX, prove that triangle WYZ is congruent to triangle WYX. Okay, here's why you need your straight edge. Once you draw a triangle about 3 lines long, not a triangle, a segment there. Okay, we're going to label it W, X, Y, Z. There's our problem. Statements. Reasons. I have no idea how many I need. I'm just going to use the rest of the page, honestly. I don't really know. Depends on what we do. Now, like the other day, it is possible, probably, to prove this with something other than side, 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 which means on your assignment today, which is a Khan Academy like lesson thing, because it's easier for you to pick and choose the pieces you need. Like I say, you're going to have to do on tests if you have that option, okay? Your homework, though, will be a mixture of all the 3 that we have learned so far, okay? Side, angle, side, 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 and angle, side, angle. But in today's notes, we're going to use side, side, side. All right, so this is not different. Start with the givens. We have 2 of them. So 1 and 2 will both be givens. Number 1, WZ is congruent to WX. Every time I see WX, I just want to finish the alphabet. Anyway, given, and I'm going to label that WZ is congruent to WX. Well, there's one side already. Number 2, WY bisects ZX. Given. Now, the first one is not something we can really use because it already gives us a side length. This one is one we're going to be able to use. It says WY bisects ZX. That means it cuts ZX into 2 congruent pieces. We've done that over and over again. Sometimes they start to feel the same after a while because there's only so many ways to do these. ZY is congruent to Z to Y, X to Y. Now, I don't know if you noticed, but I think it looks like a right triangle. But did it say it is? Did it say it's a perpendicular bisector? No. So it's not a right triangle. It would not have mattered if it was a right triangle anyway. We're using side, side, side. We don't need angles. But even if we did think it was a right triangle, this angle, side, side is not a triangle congruence theorem. Think about that. Angle, side, side. Think about what that spells. Angle, side, side. ASS. We don't have that in geometry. That does not exist, okay? Number 3. Z, Y, and X, Y are congruent because of the definition of bisector. So there is no ASS in geometry. You can see that on this right here, look. It's not on there. All right, we have a side, we need a third side, which there's only one option left, and that's this one right here. And this is the piece, we've done this over and over and over. WY is congruent to WY, but why? Because the reflexive property. We have a side, and a side. We are finished. But we are not finished until we write the proof statement. Triangle W, Y, Z is congruent to triangle W, Y, X because of the side, triangle congruence theorem. And I don't need all this extra stuff. It doesn't matter. You can leave it or erase it. So my proof is right here. Again, order did not matter in certain pieces. 3 and 4 could be swapped. 4 actually could be before the givens. We just normally don't do that. Sometimes your book will. Sometimes other things will, but we didn't need to put that before the givens. We can, because it doesn't reflect off of the givens at all. So sometimes order does not matter. That's fine. You had to have the bisect before we use definition of bisector. Okay. All right, let's do some more. We're going to do number 2 over here on page 53. We're going to do 2 and 3. Here's number 2. Given that BA is congruent to DA, and BC is congruent to DC, prove that triangle ABC is congruent to triangle ADC. Now I need my figure. A, B, C, D. Okay, statements and reasons. Again, I have no idea how much space I'll need. We'll erase what we don't need. Okay. Just like always, this is never going to change. Like I said, sometimes your book won't put the givens first. It all depends. I've got 2 givens. They go first. So number 1, BA is congruent to DA. I'll go ahead and label that. Number 2, BC is congruent to DC. Given, and I'm going to label that. All right, now here's one of the problems where order didn't matter at all. I could have put these in any order, even the third one that I'm fixing to write down. And the reason that I can do that is because they don't go together. They don't you don't have to have this one before this one because you're using a definition of anything. Because they're just telling you, hey, here's 2 congruent segments. Well, I've got 2 sides congruent. I just need a third side. So my third side is going to be that reflexive property, and it's going to be AC. So AC is congruent to AC. And that's by the reflexive property that we've used over and over again. But that's what I mean. The order doesn't matter. I could have put number 3 first because they're not one after the other. Like, you don't have to have one to be able to say the next one. So I'm finished. I've got 3 sides. That one was pretty quick. So triangle ABC is congruent to triangle ADC. This is probably the easiest one you'll ever do. And that's by, I'm using shorthand now, side, 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 triangle, congruence theorem. Okay, and I'm going to erase this because I don't need it. I'll need the space, I guess, for the next one. So I know I'm done because I was able to say the last statement here. Not a lot of extra steps there either. All right, so last problem, last proof for this lesson. This one is not my favorite. I took it from a book. And the reason this one is not my favorite is because they force you to do it by side, 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 but they can actually give you less information and you do it by side, angle, side, which is a little bit weird that they give you all of these givens just so you can do that. But, you know, they're the ones that made it up, made the big money to write this question, I guess. I don't remember if I got it from a book or where, but. So JM bisects KN, and KN bisects JM, and see what I mean is they could have stopped right there and you can prove this by side, angle, side. But they didn't. They decided, let's make this a side, side, side proof. I wonder if you can do it both ways. If you can, I'd try it both ways. It's a good practice problem. I'll actually go back and show you the side, angle, side one that we did. It's exactly the same if they had left this off. Okay, we're supposed to prove triangle JLK is congruent to triangle MLN. You might even have had the same letters. I didn't get it from the same people. It's not the same letters. It's literally on the last page, is the exact last one we just did. All right, so we're drawing, I like to call my bow tie triangles here. J, K, L, M, N. Statements, reasons. So that you understand order at the end of this, I'm really going to hound order about what had to be before what. Because there are certain pieces in this one that have to be before, and then certain ones it doesn't even matter. Like these two need to go together, you know, that kind of thing. Okay, again, no idea how much room I need. We know we have 3 givens, so that's definitely going to be a thing. So 1, 2, 3 givens. 1, 2, 3 givens. That bothers me. So that's where we're starting. Number 1, JM bisects, cuts it in 2 congruent parts, KN. Given. We can't label that on the triangle or diagram just yet because we're not ready for that. Number 2, KN bisects JM, cuts JM in half, 2, given. And 3, which we technically don't even need. We only need it if we're proving side, side, side. JK is congruent to MN. That one we can mark. JK congruent to MN. So we already have 1 side, so we just need to list 2 more sides. And that's going to come from our givens here. So let's start with this one. JM bisects KN. So KN is cut into two congruent parts, KL and NL. So KL is congruent to NL, and I'll tell you why. Those are the letters. K to L, we're going to L. L is going to be congruent to NL. And that is definition of bisector. I've forgotten how to spell definition somehow of bisector. So if that's not right, change it. Send me an email. I won't be able to fix the video. It is D-E-F-I-N-I-T-I. Yeah, that's right. Certain things don't look right. Like the other day I was looking at the word given. That does not even look right. Like, what kind of a word is that? Anyway, there are two sides now. 1, 2. I need a third one. I've already used number 1 for this one. That's what I mean by order. You had to have this statement before this one, okay? So I'm going to highlight those. These two had to go in order. It had to be 1, then 4. Didn't matter where 4 came, but 1 and 4 had to go together because you can't say 4 without 1. Number 2, we're going to use that one for 5. KN bisects JM. So JM is cut in half. So JL is congruent to ML. That is also definition of bisector. Just like 1 had to come before 4, 2 has to come before 5. Because we can't say they're congruent if I don't know that it's being bisected. Okay, that's what I mean by order matters. 3 could have gone first. 3 could have gone last. Well, not last, but after 5. It could have been number 5. The only thing that matters in the order is if you use a definition of something like bisector or midpoint or something like that, you had to have said it was a bisector or midpoint first. All right, I have side, side, side. So they are congruent. Triangle JLK is in fact congruent to MLN. By side, 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 triangle congruence theorem. And I know even though it's shorthand, you're like, why can't I just put SSS? Later, we're going to talk about triangle similarity theorems. So you need to know the difference between them and what you use. So put congruence theorem. So we are at the end. And I'm going to show you the similarity between proving this with side, side, side and proving it with side, angle, side. This is what I mean. Depending on what they give you, depends on how you can prove it. So this was side, side, side because they said here are these 3 things that have to deal with sides. However, if they hadn't given you this, your proof would have looked like this, where they gave you the bisect, but we said, hey, these opposite vertical angles are congruent to each other. You could have done the exact same thing over here, and instead of number 3, you would have put that the angles are congruent because of vertical angle theorem. So that's nice to know that you could have done it a different way. Okay. All right, so today for your homework, you're doing a little bit of all of them now. You have to determine which one you need to use.